Welcome to our first class for the week. This is a continuation of our tutorial titled the Ultimate Software Development class. In today's class, our objective is to understand how monolithic desktop applications were built, focusing on Windows and macOS application development. Then finally, we will move to web application development. On the main screen, we have the platform, tools, UI, logic, and data, which are combined to build an application that runs on Windows or Mac operating system. To build a desktop application, the IDE used is usually Visual Studio. Initially, the Win32 API or the Microsoft Foundation class were used for building the user interface of Windows application. They made use of C or C++ programming language to write their logic, while data is stored using SQLite or as a file. Later, the .NET framework was introduced, which include Windows Presentation Foundation and the Windows Form, both used for building the user interface of desktop application and use C# for writing the logic of the application. The Universal Windows Platform was later introduced to build Windows applications, providing the flexibility to use either C# or C++ for logic, while data is stored in SQL Server. With time, WinUI replaced the Universal Windows Platform, also allowing the option to choose between C# and C++ for logic, while data is stored in SQL Server. Mac application has always been built using the Xcode IDE. Cocoa was the main framework used for building its user interface, while Objective-C was used for the logic of the application. Later, SwiftUI was introduced and made use of Swift programming language for writing the logic of Mac application, while data was stored in SQL Server. Originally, desktop applications were built as one complete system. The UI, logic, and file handling are inside the same application. They run fully offline. No API is needed to function. Save files directly to your computer and are installed directly on the operating system. This is called a standalone or monolithic desktop application. Desktop applications are built as standalone systems, where the UI, logic, and file handling are integrated into a single application. They typically run offline and do not require an API to function, as they can save files directly to the user computer and are installed directly on the operating system. For building desktop application, the Win32 API and MFC were the original Windows desktop development models. C or C++ were used to write the logic of the application. They handled calculation, rules, file processing, and app behavior. The Win32 API, known as the core Windows API, were written in C and directly talked to the Windows operating system. It was used to create the UI of the application and provide Windows buttons, menu, keyboard input, mouse input, and message handlings. C is the language, while Win32 is the API. To build an interface, a developer would write C code that calls specific Win32 functions. Later on, MFC, built on top of Win32 and written in C++, became an object-oriented wrapper that wraps Win32 API into a more modern object-oriented style, providing an easier way to use Win32. You write MFC code. MFC internally uses Win32, so you don't directly write Win32 code. The Win32 API is the foundation of Windows desktop development, while MFC is a C++ framework built on top of Win32 to simplify and structure application development. In summary, the Win32 API and MFC, known as the Microsoft Foundation classes, were foundational to Windows desktop application development. The Win32 API, written in C, provides direct access to the Windows operating system and is essentially for creating user interface. MFC, built on top of Win32 and written in C++, offer an object-oriented approach that simplifies development. Together, they enable developers to create powerful and efficient desktop applications for Windows. Microsoft later introduced C# and the .NET framework to simplify desktop development, by separating the UI, logic, and data access while still producing standalone Windows applications. C# is used as the core programming language for Windows application. It handles user interaction, application rules, calculations, event handling, updates the user interface dynamically, and calls databases and other services. C# builds and controls both the UI behavior and the back-end logic in desktop application. The .NET Framework is used to build the user interface of desktop application. Each UI element like button, windows, grids are written in C# or sometimes XAML for layout, with C# controlling its behavior. WinForm allows developers to drag and drop controls like button, label, and grid in the design view. WPF is a UI framework and part of the .NET that uses XAML for layout. It helps you build rich user interface and runs on Windows only. So think of it as a modern replacement for WinForms, giving you a more flexibility and control over the look and feel of your application. XAML, known as Extensible Application Markup Language itself, is a markup language used in WPF to define the UI layout and designs. Think of it like HTML for desktop application. In summary, Microsoft introduced C# and the .NET Framework to streamline desktop application development by separating the UI, logic, and data access while still enabling the creation of standalone Windows applications. C# serves as the core programming language, managing user interaction and back-end logic, while .NET Framework, which include WPF and WinForm, provide tools for building user interfaces, with WPF offering a modern approach using XAML for layouts. The combination of these allows developers to create rich, flexible, and visually appealing desktop applications for Windows. Examples of applications created with these include Office 365 and Visual Studio. Microsoft introduced the Universal Windows Platform to unify application development across Windows devices. Due to the Universal Windows Platform limitations, Microsoft later created WinUI as a modern, flexible UI layer that can be used by both UWP and traditional desktop applications. UWP and WinUI are UI frameworks. Internally, they are built using Windows Runtime, which is a native Windows API layer written mostly in C++ that exposes API in a language-neutral way. Windows Runtime allows multiple languages to call the same API safely. When programming with C#, developers write XAML for the user interface and C# for logic. The application runs on the .NET Runtime, which uses Windows Runtime Language Projection to interact with the Windows API used by UWP and WinUI, resulting in a native Windows desktop application. When programming with C++, developers write XAML for the user interface and C++ for application logic. The application uses C++ or Windows Runtime to directly interact with the Windows Runtime API used by UWP and WinUI, resulting in a native Windows desktop application. So Microsoft created the Universal Windows Platform, known as UWP, to help developers build applications that work on Windows devices. However, UWP had some limitations, so Microsoft introduced WinUI as a new and flexible way to design user interface for both UWP and traditional desktop applications. Both UWP and WinUI uses a system called Windows Runtime, which is a set of tools that allows different programming languages to work with Windows features safely. Developers can write their app using C# or C++ along with XAML, which is a markup language for designing user interface. This combination helps them create native Windows desktop application that looks and function well. Next on our slide is monolithic macOS application. macOS followed a similar evolution to Windows, just with different name and cleaner abstraction. Objective-C was the core programming language for building macOS desktop application logic. It handles the application behavior, business rule, event responses, and data processing. Cocoa, on the other hand, is Apple desktop application development framework, which provides windows, menu, buttons, text field, dialogues, and event handling that allow developers to create the UI of desktop application using an interface builder, which is a visual tool inside the Xcode editor. So macOS applications were built using Objective-C for application logic, Cocoa for the user interface and system services, and Core Data or SQLite for data storage, all packaged as a standalone desktop application. Apple wanted safer code, faster development, and modern language features. This led to the introduction of Swift in 2014. Swift is a programming language that handles the logic, application behavior, events, business rule, etc. Cocoa remained the framework used to build the user interface with Storyboard until 2019. Swift UI was introduced by Apple in 2019 as a declarative UI framework written entirely in Swift with one code base for macOS, iOS, iPadOS, and watchOS. It allows developers to reuse the same UI code across these Apple platforms, making apps development faster and more consistent. The evolution of macOS application development has seen significant changes, beginning with Objective-C as the core programming language and Cocoa framework for building user interface. With the introduction of Swift in 2014, Apple aimed for safer code and faster development, leading to a more modern programming approach. Swift UI, launched in 2019, further enhanced this by providing a declarative UI framework that allows developers to create applications for multiple Apple platforms using a single code base. Next on our slide is the monolithic web application. To build a monolithic web application, developers initially used Notepad to write HTML, CSS, and basic JavaScript code to build a website. Later on, VS Code was introduced, which allowed PHP developers to use HTML templates for the user interface of a web application, while the logic is written in PHP and then connect to SQL database for storing data. As time goes on, developers began to create framework which enable them build web application easier and faster. Developers who code with PHP use Laravel for building their web application, incorporating HTML templates for building the user interface. Developers who code with Python use the Django for building their web application, incorporating HTML templates also to build the user interface. Developers who code with Ruby used the Ruby on Rails framework to build their web application, while using HTML templates for the interface. Developers who code with Java used the Spring framework, while incorporating HTML templates for building the user interface. Developers who code with C# used the ASP.NET framework to build their web application, while using HTML templates for the user interface. A monolithic web application is one where the UI, application logic, and data assets are all built, deployed, and run as a single application. Early web applications were static and built with HTML, CSS, and basic JavaScript. There was no back-end logic, no database, and the page were static. Dynamic web applications began in the late 1990s to the early 2000s and had HTML templates, back-end logic, and database query inside one application. Here, a PHP file contains HTML for the UI, PHP for the logic, and SQL query for database manipulation. Structured monolithic web application began in the mid-2000s to early 2010. Developers introduced structure to monolithic by introducing frameworks like Laravel, the Django, Ruby on Rails, Spring, ASP.NET, which supports simple deployment, easy debugging, and are perfect for small to medium teams while following the MVC pattern. Monolithic web applications have evolved significantly over the years. Initially, they were static and built using HTML, CSS, and limited JavaScript, lacking back-end logic and database. As technology progressed, dynamic web applications emerged in the late 1990s and early 2000s, incorporating HTML templates, backend logic, and database query within a single application, often utilizing PHP for development. By the mid-2000s to the early 2010, structured monolithic web applications began to take shape as developers introduced frameworks like Laravel, Django, Ruby on Rails, Spring, and ASP.NET. These frameworks provided essential features such as easy debugging, simple deployment, and adherence to the MVC pattern, making them suitable for small to medium-sized teams. This evolution reflects the ongoing effort to enhance developers' efficiency and improve application performance within monolithic architectures. Developers who code with PHP use Laravel, a full-stack web framework created with PHP to build full-featured web applications. The logic of the application is written in PHP, and dynamic data is inserted into the UI through a method called templating. Database models are written as PHP classes, and the data is stored and managed in the database using Eloquent ORM. Below is an example of a Laravel code where a blade templating is used to display data on the user interface, which is usually HTML templates. Developers who code with Python uses Django, a full-stack web framework created with Python to design monolithic web applications. The logic is written in Python, while the UI is an HTML template. Dynamic data is injected into the UI using a templating system called the Django template language. The database models are written as Python classes, which the Django ORM uses to create the actual database table and to store and manage data in the database. Below also is a code written in Django using a Django templating language to display information on the user interface. Developers who code with Ruby use Ruby on Rails, a full-stack web framework created with Ruby to build monolithic web applications. The logic is written in Ruby, while the UI is an HTML template. The database models are written as Ruby classes, which the Active Record ORM uses to create the actual database table, to store data and manage data in the database. Rails is actually the framework that inspired Django and Laravel. Ruby on Rails is a powerful full-stack web framework that allows developers to create monolithic web applications with ease. In this framework, application logic is written in Ruby, while the user interface is designed using HTML templates. Dynamic data is seamlessly integrated into the UI through a templating system known as ERB templates. Database models are defined as Ruby classes, which the Active Record ORM leverages to generate the corresponding database table and manage data effectively. Notably, Rails has also served as an inspiration for other frameworks like Django and Laravel, highlighting its significant impact on modern web development. This combination of features make Ruby on Rails an excellent choice for building robust and scalable web applications. Developers who code with Java use Spring Boot, a large enterprise framework written in Java to build a monolithic and enterprise applications. The logic is written in Java, while the UI is an HTML template. Spring uses a server-side templating system called TimeLeaf to inject dynamic data into the UI. The database models are defined as classes written in Java, which are then mapped to the database table using the Hibernate ORM. The Hibernate ORM also handles data storage and retrievals. So below we have an example of code written in Spring, where the TimeLeaf templating system is used to display data on the user interface, which is usually HTML templates. Spring is a robust enterprise framework built in Java that facilitates the development of monolithic and enterprise applications. In this framework, application logic is implemented in Java, while the user interface is structured using HTML templates. To incorporate dynamic data in the UI, Spring utilizes a server-side templating system known as TimeLeaf. Database models are defined as Java classes, which are mapped to database table through the Hibernate ORM. a powerful tool that also manages data storage and retrieval. This combination of features makes Spring an excellent choice for developers aiming to build scalable and maintainable enterprise applications. Time-leaf look like HTML attributes, which is why Java developers like it. Developers who code with C# uses ASP.NET, a Microsoft Web framework created with C# to build monolithic and API-based applications. The logic is written in C#, while the user interface is an HTML template. ASP.NET uses a templating system called Razor Templates to inject dynamic data into the user interface. The database model are defined as classes written in C#, which are then mapped to the database table using the entity framework. The entity framework ORM also handles data storage and retrievals. So here is an example of code written in ASP.NET using the Razor templates to display data on the user interface, which is usually HTML templates. ASP.NET is a powerful web framework developed by Microsoft using C# that enables developers to create both monolithic and API-based applications. In this framework, application logic is implemented in C#, while the user interface is structured using HTML templates. To incorporate dynamic data into the user interface, ASP.NET employs a templating system known as Razor templates. Database models are defined as C# classes, which are mapped to database table through the entity framework, a robust object relational mapping tools that also manages data storage and retrievals. This combination of features make the ASP.NET an excellent choice for building scalable and efficient web applications. Also note that Visual Studio IDE is different from Visual Studio Code IDE. Visual Studio is a full-featured integrated development environment designed for professional developers working on complex applications, particularly those using .NET technologies, offering advanced debugging, profiling, and project management tools. While Visual Studio Code is a lightweight open source code editor that is more flexible and extensible, ideal for quick coding tasks and smaller projects across various programming languages, focusing on speed, simplicity without the extensive feature of a full IDE. HTML templates used in this context consist of HTML, CSS, and JavaScript, which was used to build the user interface of these monolithic web applications. Templating is what allows us to put dynamic data into HTML. A template is HTML with placeholder and then simple logic. It is not front-end JavaScript. ORM maps programming language classes model to database table and handles data storage and retrievals. It allows developers to work with the database data using programming language objects instead of writing raw SQL all the time. So you do not need to write the raw SQL code throughout the building of your application. We have come to the conclusion of today's class, and it's time to see if we are actually following up in the class. We have few questions to answer, and the questions is a continuation of the previous class we had, where we stopped at question 8. When I read through the questions, all you have to do is provide the correct answer in the comment section. If the answer is B, just comment 9B. Okay, number 9 says, why were early Windows desktop applications mainly developed using C or C++? A, because C and C++ are scripting language used for UI design. B, because Win32 and MFC require low-level control to directly interact with the Windows operating system. C, because C and C++ were used only for database storage. D, because .NET and C# did not support desktop application. And lastly, because C and C++ were designed only for web application. Put down the correct answer below. Number 10 says, what is the main difference between Win32 API and MFC in Windows desktop development? A, Win32 is written in C++, while MFC is written in Java. MFC directly replaced the Windows operating system. Win32 is the core Windows API, while MFC is a C++ framework built on top of Win32. Win32 is used only for database, while MFC is used for UI. MFC does not rely on Win32 at all. Number 11. In .NET Desktop Application Development, which combination is correct? XAML handles logic, while C# handles UI design. C# handles application logic, while Win32 handles UI layout. C# controls logic and behavior, while WPF and WinForms defines the UI. HTML is used for UI and C# is used for database only. .NET applications do not run as standalone applications. Number 12. Which statement correctly describe monolithic web application using framework like Laravel, Django, or Ruby on Rails? A. UI, logic, and database are deployed as separate services. B. They are suitable only for large distributed systems. C. The logic, UI template, and database access exist within one application. D. They do not use any templating system. And E. They cannot interact with databases. Thank you for staying to the end of the class. Like I always say, there is a lot to learn, and if you are not subscribed to the White Hat Developers, then subscribe, because this is what we are here for, to help you learn and understand the concept of software development. See you in the next class.